All right, welcome to Success is 101 class. Today we want to look at work, energy, and power. This is chapter 5 of Physics 101, Mechanics and Properties of Matter. This is chapter 5. We've done 1 to 4 already. Chapter 1 talking about systems of measurement. Chapter 2 talking about kinematics, motion, linear motion, projectile motion, free fall motion, instantaneous velocity, instantaneous acceleration, velocity time graph, displacement time graph. That was chapter 2. Chapter 2 has been done already. If you missed the class, kindly message me so I can send you a full detail of the class. Chapter 3 is talking about vectors. We did vectors. There's also a recording of that class, chapter 3, vectors. Chapter 4 is dynamics. We have also done dynamics and is on record already. Dynamics, talking about forces, Newton's laws of motion, Newton's first law of motion, second law and third law, and the calculations involved. Now, chapter 5 is talking about work, energy, and power, and that's where we are now. So we're going to start with work. Let's start with what? Work. Work is said to be done, right? And work is said to be done. Work is said to be done when a force F moves a body of mass M from one point A to another point B, covering a distance D. Work is said to be done when a force F moves a body of mass M. Work is said to be done when a force F moves a body of mass M from one point A to another point B, thereby covering a distance D in the process. Thereby covering a distance what? D in the process. Work is said to be done when a force F moves a body of mass M from one point A to another point B, covering a distance of what? D in the process. Covering a distance D in the process. We say work is said to be done. Work is said to be done. Class, it therefore means that mathematically you can say work is force, product of force and what? Distance covered. Work is a product of force and distance covered. Work is a product of force and distance covered. Class, but this formula could change depending on what exactly happened during the work done, class. If this is the body that is acted upon, class, this body is at rest currently, and the force acting on the body is acting parallel to the plane where the body is located. Class, because this force acting parallel to the plane, it is not making any angle with the horizontal because it's parallel. Two lines that are parallel do not make any angle to each other. There's zero angle between two lines that are parallel. So this is the plane, and the force acting parallel to the plane with zero angle to the plane, class. The work done in this kind of situation is just force times distance, force times. But class, this formula could change if the force is not acting parallel to the plane like this. If the force acting at an angle, another formula will come out. If the force acting at an angle, theta, to the horizontal. If the force is acting at an angle, theta to the horizontal, our work done will not just be force times distance, but force times distance cos theta. Force times distance cos, because in this case, the force acting at an angle. In the first case, the force is acting at no angle. There was no angle between the force and the horizontal. So that one is work done is force times distance for the first case. But the second case, class, the force is acting at an angle to the horizontal, and the angle is theta. The angle is what? Theta. So for this one, our work done is force times distance cos theta. But class, we have another case scenario. You can write down work done against gravity. Work done against gravity. Work done against gravity. Class, the work done in pulling a body up against gravity. Because when you're moving a body up, that body is definitely going against gravity. Class, in this formula, the work done is the mass of the body times the acceleration due to gravity times the height. How high did you pull the body up? How high did you pull the body what? So it's the mass times the acceleration due to gravity g times the height attained h. So it's mgh for this one. Work done against gravity, mgh. mgh. And we still have a fourth one. Class, the fourth one we have work done on a body on an inclined plane. Class, let us have an inclined plane like this, and this is a body on an inclined plane. Class, this still work done is actually the body is being put up against gravity because we're looking for the work done in pulling this body up an inclined plane. Work done in pulling this body up an inclined plane. Class, we must consider the heights. Also the length of the plane, L. And this inclined plane has an angle theta to the horizontal, class. So the work done that will be needed to pull this body up this inclined plane is W equals to mgl sine theta. mgl sine W equals to mgl sine work done in pulling the body up an inclined plane. Work done in pulling the body up mgl sine theta. Work done in pulling the body up an inclined plane. mgl sine theta. Let us take some questions now. A 250 kg elevator cage, a 250 kg elevator cage descends 100 meters within a high-rising building. Descends 100 meters within a high-rising building. Descends 100 meters within a high-rising building. A 250 kg elevator cage, a 250 kg elevator cage descends 100 meters within a high-rising building. What is work done by gravity on the elevator cage during the displacement? During the displace, what's the work done by gravity on the elevator cage during the displacement? What's the work done by gravity on the elevator cage during the displacement? A 250 kg elevator cage descends 100 meters within a high-rising building. What's the work done by gravity on the elevator cage during the displacement? Class, once you hear work done by gravity or work done against gravity, the formula that should come to your mind should be mgh. Class, a 250 kg elevator cage, mass of the cage is 250 kg. Height, this is 100 meter, 100. Class, your G is acceleration due to, class, whether you are given or not, is 10 meter per second square. It's a constant. We all know that. The acceleration due to gravity is 10 meter per second square. With these three, you can easily get your work done. 250 multiplied by 100 multiplied by 10. 250 multiplied by 100 multiplied by 10. Who has passed question there? Anybody who passed question there? Class, work done measured in joules. Measured in what? Joules. 250 times multiplied by 100 multiplied by 10. What would that give us? 250,000 joules. Yes, 250,000 joules. Correct, 250,000 joules. Let's take another question. Hope we've done writing that. A 60 kg man walks up a flight of stairs. A 50 kg man walks up a flight of stairs 15 meters high. A 50 kg man walks up a flight of stairs 15 meters high. How much work is done against the force of gravity? How much work is done against the force of gravity? How much work is done against the force of gravity? Go ahead and solve that. Go ahead and solve that. Let's see what you have. Go ahead and solve that. Go ahead and solve that. How much work is done in pulling what? Against the force of gravity. A man, another question. A man pushes a truck with a force of 40 Newton. A man pushes a truck with a force of 40 Newton. A man pushes a truck with a force of 40 Newton at an angle of 20 degrees downward from the horizontal. At an angle of 20 degrees downward from the horizontal. A man pushes a truck with a 40 Newton force, with a force of 40 Newton at an angle of 20 degrees downward from the horizontal. At an angle of what? 20 degrees downward from the what? Horizontal. Find the work done by the man. Find the work done by the man if it covers a distance of 20 meters in the process. Find the work done by the man if it covers a distance of 20 meters in the process. Find the work done by the man if it covers a distance of what? 20 meters in the process. Class, this was the first one. I believe you are done with this. 250 times 100 times 10 is 250,000 joules, right? In your option, you might not see this. It might change to kilojoules. It might change to what? You're looking for your answer in the option. You're not seeing it. You divide this by 1,000, you change to kilojoules. 250 kilo. Divide this guy by 1,000, you change it to what? To kilo. So please be very careful before you ascertain that there's no answer in the option. Sometimes your answer has just been converted to another unit. Sometimes your answer has just been converted to another unit. From joules to kilojoules, just divide by 1,000, 250 kilojoules. Let's now solve the questions we've been given. Claire, what's the first question? A 60 kg man, mass 60 kg, yes. Walks up a flight of stairs, height 15, yes. How much work is done against the force of gravity? Take G as 10 meters per second. Class, is obvious, right? 60 mgh. Work done against gravity, mgh. 60 times 10 times. 60 times 10 is 600. 600 times 15 is 9,000 joules. 2 kilojoules is what? 9 kilo divided by 1. From joules to kilojoules, divide by 1,000. You have 9 kilojoules. Okay? Yes, it's a constant. Acceleration to gravity is a constant, 10 meter per second square. What's the next question? A man pushes a truck, yes, with a force of 40 Newton, yes. Theta is 20 degrees at an angle of 20 degrees downward, yes. Cover a distance of 20. Class, it covers a distance of 20 meters. Work done in this kind of situation is FD cos force times distance cos theta. F, force is 20. D, distance covered is 20. Cos 20 degree. 20 times 20 is 400. Someone should do cos 20 degree for us. What do we have? Eh? Force is 40 Newton. Sorry, force is 40. The force is 40 Newton. 40 times 20 is 8. Cos 20 degrees what? 0.4. Just 0.4. No, don't just throw away those 08 now. 40 what? 4080. Cos 20. Please be checking your calculator well, please. (0.9397), approximately 7. So what is 800 times 0.9397? You say 751.76 joules. 751.76 joules. You say? Oh, you prefer sign? It's not a valid question because the formula says cos theta. So when someone has told you cos, the formula has been derived already. FD cos theta. If you want to go into why it is cos and not sine, I'll need to now explain the horizontal and vertical component of the force. Because if you look at this, F is making an angle theta to the horizontal. So the distance covered D, if this is my opposite, this is my hypotenuse, the longest side, and this is my adjacent. Using SOHCAHTOA to get the resultant, which is this side, I must now say cos theta equals to adjacent D all over the hypotenuse F. Now the force acting like this, which is F. Find out that you have F cos theta. Now bringing into the formula of work done, you now say FD cos theta. So that's how we have cos theta as our what? As our work done. Now moving forward, let's take this question down. If a rifle fires a bullet of mass, if a rifle fires a bullet of mass, if a rifle, R-I-F-L-E, R-I-F-L, if a rifle fires a bullet of mass 0.01 kg, if a rifle is like a gun. If a rifle fires a bullet, class, this is not under work energy and power, but this particular question, I want to take it because it's popularly asked, and I want to take note of the formula for this particular question. If a rifle fires a bullet of mass 0.01 kg with a velocity of 300 meters per second, with a velocity of 300 meters per seconds. If a rifle fires a bullet of mass 0.01 kg with a velocity of 300 meters per. So mass of bullet, class, 0.01 kg with a velocity of bullet 300 meters per. Find the recoil velocity if the mass of the rifle is 6 kg. Find the recoil velocity if the mass of the rifle is 6 kg. Find the recoil velocity. If the mass of the rifle is 6, find the recoil velocity. If the mass of the rifle is 6 kg. Class, if they say a rifle, or you hear a question like a gun, or a cannon, or a revolver, fires pellets of so and so, fires bullets, fires this, fires that. Class, the formula you have to use is mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. Class, you can put a negative here to represent the recoil velocity of the gun. Mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. The mass of the gun is 6 kg. Velocity of gun is what you're looking for. It's called the recoil velocity. Mass of bullet is 0.01 kg and velocity of bullet is 3. This is the formula that will deal with questions like this. So when you see questions like if a gun fires a bullet, if a rifle fires a bullet, mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. Let the negative sign be here to show the recoil. Because class, for the bullet to go forward, the gun must have a recoil, experience a recoil. Divide both sides by minus 6. Minus 6 cancels minus 6. So you have 0.01 times 300 divided by minus 0.01 times 300 is 3. 3 divided by minus 6 is minus 0. Meter per. This is the recoil speed of the gun. This is the recoil speed of the what? Of the gun. Class, our topic is work, energy, and power. We just digressed here quickly. So if you see any question like a gun fires a bullet, a cannon fires a bullet, any bullet was fired in one direction or the other, find the recoil speed, class. This formula will do it for you. Let's quickly go to energy. Energy. We are done with work. Let's go to energy. Energy is defined as the capacity of doing work. Energy is defined as the capacity of doing work. Energy is defined as the what? Capacity of doing what? Work. Class, energy and work don't have the same unit, joules. They are measured in what? Joules. But the big difference between energy and work done is that in work done, work is actually done. Energy is the capacity. Capacity to do work doesn't mean that work is done. If I ask you, do you have the capacity to lift this phone? You can, right? But did you lift it? No. So work has not been done, but the capacity is there. The energy is there to do. So we can calculate the energy that's required to do a particular activity, even if the activity is not being done. But what energy will be required? It could be an hypothetical situation. What energy will be required to carry so and so from one point A to point? And we have two types of energy. We have the potential energy. The energy of a body at rest. Now, when we talk about mechanical energy, because we have different forms of energy. But our focus will be on mechanical energy because we are dealing with mechanics and properties of matter. Because we are dealing with mechanics and properties of matter, our focus will be on mechanical. We have sound energy. We have electrical energy. We have chemical energy. Different types, forms of what? Energy. But focus will be on what? Mechanical energy. So class, having defined energy as capacity to do work, we want to look at mechanical energy. Class, mechanical energy is the energy of a body due to its position or its state of motion. Mechanical energy is the energy of a body due to its position or its state of motion. Mechanical energy is the energy of a body due to its position, put potential, or state of motion, put kinetic. Mechanical energy is the energy of a body due to its position, in bracket, put what? Potential. Mechanical energy is the energy of a body due to its position, in bracket, put potential, or a state of motion, put kinetic in bracket, or state of motion, put what? kinetic in brackets. Class, when the body is at rest and is not moving, the energy that's stored in that body is the potential energy. When the body is in motion, the energy that enables the body to move in motion is kinetic, and that's how we have potential energy and kinetic energy. Class, potential energy is mgh, kinetic energy is half mv. Class, we have what we call law of conservation of mechanical energy. Write down law of conservation of mechanical energy. Law of conservation of mechanical energy. Law of conservation of mechanical states that the total energy total mechanical energy of a body at each point of motion is a constant. Total mechanical energy of a body at each point of motion of the body is a constant. Total mechanical energy of a body at each point of motion of a body is a what? Is a constant. Look up. Let me show you. That means that the total mechanical energy of a body is conserved, notwithstanding the point of motion of the body. That is, the total mechanical energy of a body is conserved, notwithstanding the what? The stage of motion of the body. The total mechanical energy of a body is conserved, notwithstanding the stage of motion of the class. What that means is this. When you want to look at total mechanical energy of a body, is the summation of the potential plus the kinetic. The total mechanical energy of a body is the summation of the what? Potential energy and the what? Kinetic. Class. Let's consider the case study of a ball falling from a height h. A ball falling from a height what? H. Let us say that before the ball started falling, total energy in the system is 120 joules. The total energy in the system is 120 joules. Class, I must inform you that before the ball starts falling, one thing I need you to note is that potential energy, write down note. Potential energy is maximum at maximum height. Potential energy is maximum at the maximum height, while kinetic energy is 0. Potential energy is maximum at maximum height, while kinetic energy is what? 0. But as a body is falling down from the maximum height, the potential energy reduces and the kinetic energy increases. As the body is falling down from the height, the potential energy does what? Reduces, while kinetic energy does what? Increases. As the body is dropping down from the maximum height, the potential energy reduces, kinetic energy does what? Increases. That is, the kinetic energy increases with increase in speed, class. When the body is coming down, it's falling in favor of gravity. The speed is increasing as it's coming down. It's increasing, and it will attain its highest speed just before it hits the ground. A body has its highest speed when falling from a height downward, just before it hits the... So, I want to explain the dynamic between potential and kinetic energy for you. For a body falling from a maximum height. For a body falling from a maximum height, you need to understand the dynamic between the potential and kinetic. Class, if total energy in the system is 120, remember, total energy in the system is summation of potential and kinetic. Class, the potential takes the whole 120 and kinetic takes 0. So that 120 plus 0 is still 1. Don't forget that total energy, total mechanical energy must be conserved, 120. At every stage in motion of this body, by the time you add up potential plus kinetic, you must always have 1. That's what the law of conservation of mechanical energy is talking about. That every stage of motion of this body, as it's falling down, the total mechanical energy remains is conserved. It never changes, never. Class, so at maximum height is conserved. Potential energy is maximum, takes the whole 120. Kinetic energy is what? Because there cannot be kinetic energy for a body at rest. For a body at rest, kinetic energy is 0. Because if you are at rest, it means that your velocity is 0. And half mv squared, if v is 0, 0 times m makes kinetic energy 0. So when a body is at the maximum height, before it starts falling, is at rest, potential is maximum, kinetic is 0. As this body is falling, class, the potential will be reducing, kinetic will be, but the summation of potential plus kinetic must still be conserved, 140 plus 80, 120. At midway point, class, the potential energy equals to the kinetic. You could be asked a theoretical question, theoretical physics. At what point in motion of a body is the potential equals to the kinetic when falling from a height downward? At midpoint of motion of a body, the kinetic and the potential are equal, but class, still, the total mechanical energy is still conserved. 60 plus 60. As you're almost hitting the ground, kinetic is even increasing further, potential is reducing, and just at the ground level before it hits the ground, kinetic is maximum, 120, potential is 0. These are the changes that occur between potential and kinetic energy for a body falling from a height downward. Class, do you know the importance of this thing I'm telling you? Because at midway point, potential equals to kinetic. What does this mean, class? What does this? They could give you a question to find the kinetic energy of a body at midway point. But class, they are asking you to find kinetic, and they are giving you parameters for potential. Class, imagine giving you mgh, and they say you find kinetic. So why did they give me velocity? They did not give me velocity. I thought because to get kinetic, you need velocity, half mv. They are giving you parameters for potential, but they're asking you to find kinetic. They are trying to test whether you know that you can say sometimes kinetic can be mgh, class. Kinetic energy is mgh at midpoint. At midpoint, kinetic energy can be mg, and potential energy can be half mv squared at mid. So these two formulas can be interchanged because at midpoint, potential equals to kinetic. Yes, only at midpoint. So there's a point in motion of a body that you can use kinetic energy formula to get potential. And you can use potential energy formula to get kinetic. Why are they giving me mgh? Now they say you should find kinetic. It's wrong question. Kinetic is half mv squared. Where's my v now? But they're giving me mgh for potential. I say, did they want to ask for potential? Were they making a mistake? No. They want to see whether you understand that at midway point, potential equals to, and just use mgh, you still have the same. Of course, you can still go through the stress of getting velocity if they didn't give you. But that will take more time. You will now use the equation of motion. If you have h, the body falls, right? So u is 0. Use the equation of motion. Maybe v squared equals to u squared plus 2gh. G is 10 meters per second square. You can get v. You understand? But it might take more time. But you that understands that I can just use mgh. You'll be faster than someone that is trying to get v first. Now, class, this is for when a body is coming down. Can we also study the dynamics of a body's potential and kinetic energy when the body is going up against gravity? We have looked at when the body is coming down. Let's look at the changes that occur when the body is going. When going up, class, before the body starts moving up, the kinetic is maximum. Kinetic is what? So if total energy in system is 120, kinetic is 1. Potential is that before the body starts going up, kinetic is 120. Potential is what? Because before it's now, as soon as it moves up, kinetic starts reducing. Potential starts at midway point, they are the same. At this point, potential takes over. At maximum height, potential is maximum. Kinetic is, because at maximum height, there's no longer movement. It has gotten to the highest point. There's no longer movement, right? And when there's no movement, kinetic energy does not exist because it's 0. These are the changes that occur between potential and kinetic. We'll take a question on this soon. Quickly write down while we look for questions. A bullet of mass 0.002 kg is moving with a velocity of 500 meters per second. Is moving with a velocity of 500 meters per. What is the kinetic energy? Is that not a dream question for a student? A bullet of mass 0.002 kg, they give you mass. Is moving with a velocity of 500 meters per. Imagine giving you mass and velocity and say find kinetic energy. What do you do? Half mv. So not all questions will be difficult. Not all questions will be easy too. Now someone is busy solving. You now left this question because you want to solve number one first. Then I collected your script. You now saw it at the end. I can solve this now, but no time again. Bring your script. So when you start an exam, I always advise students, screen all the exam questions and pick out all the easy questions. In every exam, 35, that they give 35 questions. There might be 10 to 15 questions that will not stress you. Pick out and clear those ones out. So 15 is sure. 15 sure means that you can never fail that course. 15 times 2 is 30. You just need 10 from your CA, 40. Anything 40 and above. And you have escaped F. Now you are calm. Okay, no more F. Yeah, let me start solving. Let me start. You have cleared like 10, 15 questions that are easy. There are questions that are easy, but they'll be tough ones. They'll be there. They'll be tough ones. They'll be. So when you start your exam, select all those simple. It might be number 35, number 25, number 10, number 15. Just go through them. No rule say you must start from number 1 first. There's no rule like that. I've started the exam from the end before 35, 34, 33. I noticed that the ending was more simple. I started picking it from there. What some people are suffering in number 1, they're still number 1 since. I've done 35 to like 20. You are still number 5 because you want to do 1 to 5. We will carry the same mark. All questions carry the same. Now let's go. You see half mv square and you are done. Look at this one. A ball of mass 0.4 kg, another bonus. Every exam has simple and difficult questions. A ball of mass 0.4 kg is released from a height of 30 meters. A ball of mass 0.4 kg is released from a height of 30 meters. What is the potential energy on impact to the ground? A ball of mass 0.4 kg is released from a height of what? 30 meters. What is the potential energy on impact to the ground? But class, solve. A ball of mass 0.4 kg is released from a height of what? 30 meters. What is the potential energy on impact to the ground? mgh, right? And what is the final answer? 1. Yes, but you are wrong. You are. What is the potential energy not at maximum height but on impact to the is 0? Is what? When the body is falling down, what did I tell you? Potential energy is reduced. At this impact to the ground, what do you have? Be careful. Be careful. Class, be careful. There's a reason why we explained it, that when the body is coming down, class, at maximum height, potential energy is max Z. But as it's falling down, what happens? It's reducing. Questions like this, option A will grab 120, you will rush it. You know, in exam now, you are rushing. Number A, they will put that wrong one. That's popular answer in A, so you can rush it. Under exam tension, A, 120. I don't finish this one. Chapter God. Class, are we together? You see why I was not wasting my time explaining this. So it's not just enough to know that people know that potential energy is mg, but you have missed this question like this. And you know, simple question like that, but you have missed it. All right, class. Yes, now let's go to power. We have looked at work, we have looked at energy. Let's look at power. Power class. Power is simply what? Work done divided by time is power. The product of force times distance all over what? Time. You have power. Force times distance all over time. So power is work done all over time. Actually, the simplest exam you have in this will, mark my word, when you finish all your paper, you will know the one that was very easy. It's physics. Physics does not like stressing year one students. It's when you get to 200 level. But many of you are lucky. After year one, you're not doing physics again. You still do physics second semester. There's 2 physics second semester waiting for you. Physics 115 and physics 112. Some of you will do 115, some of you will do 11. So in second semester, we will do this. The physics will split the class. Because some departments will be offering 115, waves and optics. Waves and then some will be doing 112, electricity and magnetism. That one, that magnetism is, we have waves and optics. In the wave part, you'll be doing all those concave lens, convex lens, radius of curvature, center of curvature, principal focus, principal axis. The electricity, you'll be looking at Lenz's law, Faraday's law, the solenoid, Bauer-Sabat's law. That's electricity generator. You study the transformer. Those in anatomy is 112. Then those in microbiology, AEB, 115. SLT is 112. Engineering, 11. So pharmacy is 115. Now, you know the good thing? Those doing 115, you're not doing physics practical second semester. Those doing 112, you're still doing physics. So those doing 112 will spend more than those doing 115 because 115 is going to buy manual. Since they're not doing practice. Some of you, why you're buying your test because of the manual, I don't lie, right? Because of the manual. So any course that is not doing practical, you don't need to go and buy the manual because you don't have practical for it now. So those doing 115, you will not do practical. But those doing 112, you're already happy. Pharmacy, happy? But those doing 112, you're doing physics, practical. But everybody will do chemistry practical. We have 2 chemistry second semester, Chem 131 and 132. So 131 is chemical kinetics, 132 is organic. So you have 2, everybody's doing 2 chemistry second, except AEB. AEB is doing only 1 chemistry. So that's that for that. Power is work done over time, class. Do you know what makes power interesting? Because everything we have done in work done is the same formula for power, just that we divide by. So if we have 4 formulas for work done, we also have 4 formulas for power. Although we have another 1 formula, which I'll show you. But work done, when it is force times distance, you have force times distance all over. First formula for power. What's second formula for work done? MGH, right? So power can be MGH all over time. What's third formula for work done? FD cos theta. So power can be FD cos theta over. And what's the last one? Like MGL sin theta, right? So power can be MGL sin theta all over time. But no more mathematics second semester. No maths. Only engineering and infotech, cybersecurity will do maths. Every other person, you're not doing maths again. For second semester, yes? Yeah, L means the length of the inclined plane. L means the length of the what? Inclined plane. MGL sin theta over T. So these are the 4 formulas for power. Since we have 4 formulas for work done. For power is simply work done all over time. So if you have understood work done, you have understood power. It's just to divide by time. If you can get work done, you can get power. Just that in power, they will give you time. So you can divide the work done by time. You can divide the work done by what? Time. So questions? It's not possible for them not to give you time. I say, except you are asked, power can also be force times velocity. Force times. If you don't give in time, then power can be force times what? Velocity, except in that case, yes. Let's take this question. A man of mass 50 kg. A man of mass 50 kg. ascends a flight of stairs. A man of mass 50 kg. A man of mass what? A man of mass 50 kg ascends a flight of stairs 5 meters high in 5 seconds. Ascends a flight of stairs 5 meters high in 5 seconds. A man of mass 50 kg ascends a flight of stairs 5 meters high in 5 seconds. If the acceleration due to gravity is 10 meters per second square, if the acceleration due to gravity is 10 meters per second square, if the acceleration due to gravity is what? 10 meters per second square, calculate the power expended. Calculate the power what? Expended. Calculate the power what? Class, power is measured in watts or horsepower or what? Class, this question they ask in your exam, 1 horsepower is equivalent to how many watts? 7 what? 746 watts. How come you know it so fast? Eh? You've done it in the past question. You're smart. So people have started doing the past question. God bless you. God bless you. That's good. Because some questions will be repeated. Some questions will be what? You started doing the past question. That's good. Class, exam is very close. You know this is the last day of February. Today is the last day of what? Once you have entered March, class, according to the calendar, they fix your exam for March. But they will shift it a bit. It might be 2 weeks. It might be 1 week. It might be 3 weeks. Highest 3 weeks. So your exam is already less than 2 months away. Because this is the last month, day of February. February is very short. February is very... According to the school, now the school resumed last year, December. So that's December, January, February. What are you still doing now? Exam March. A semester is 4 months. Or you want to do 6 months semester? You resume December. Some of you did not come because it was just 2 weeks to Christmas, Abi. You say, let me just resume January. Please, I'm recording the class. And you could have called me and you signified me. What do you need? 211. 211. What's your name? Christian. Okay, they'll bring it for you. Please, where's that my guy? Don't forget, power can be force times velocity. Force times. If they don't want to give you time, they don't want to give you time. Okay, look at it. 1 horsepower is equivalent to question 25. You see it? 1 horsepower is equivalent to... Class, what they did last year, they gave 20 OBJ questions and the remaining 15 were subjective. Please, if you got a past question by December or early January, there's 1 year later, they update the latest that are missing in your past question. Message me so I can send it to you. There's 1 year. I had not gotten the latest year then. Yes, 2023, 2024. The one in your past must probably be 2022, 2023 is the highest. There's 1 more year in each course. 2023, 2020 is ready now. Those that bought recently, you have it. If you bought throughout February, it's there. But January people, your own stopped 2020. There's 1 more year I'm supposed to add for you. So please, maybe I'll post on the past question. We have a past question group. I'll post it there. If you have gotten our past question, message me to add it to our past question group. If you've gotten the past question, message me to add it to the past question. It's always good to have the latest year of any person you're studying. Do you know why? Because that's where they recently set, right? The way they are setting it currently. You don't want to be studying 10 years ago past question. They haven't changed the lecturer that set it. Because the aim of studying a past question is to know the mind of the lecturer, right? And if you're studying an old lecturer mind that's not setting an exam for you again, what is it you need? So you need the current, the one that they are setting currently, the one that the lecturer just taught last set very recently. It's very, very... So message me, please. It's probably, if you bought your past question in December, those that resume December or early January. But no, from February, I started adding it. I started adding it for February. February, if you bought February, your own is, you are covered. But if you check your past question, you don't see 2023, 2024. That's your set. Christy, your set is 23, 24 now, last set. Her set, she's in 200 level now. She was in her class last set. There is their set. The exam they wrote, I have it now, so it's in the past question. If you don't have it, you don't have the latest year. So you see them coming to buy year 2 past question because year 1, he helped them. That's why they are coming back to buy year 2. No, they don't. Come. You gave her the wrong one. That's for PIC. A machine is a device that enables a large load to be overcome by little effort. A machine is a device that enables a large load to be overcome by little effort. A machine is a device that enables a large load to be overcome by what? Little effort. Class, if you have a load, so we're in machines now, this is the last one under work energy and power. A load of 500 Newton, normally, you require an effort of 500 Newton normally. Normally, to balance things out, a load of 500 Newton should need 500 Newton force to overcome it, or effort to overcome it. But class, a machine can allow you to use a lesser low effort of 200 Newton. Imagine 200 Newton overcoming 500 Newton. Normally, it should not be possible. But a machine allows you to use a little effort to overcome a large. What allows that to happen is what we call the mechanical advantage of the machine. Mechanical advantage. Thank you. Mechanical advantage of the machine, which is the load divided by the mechanical advantage is load divided by the what? Effort. Load over effort is mechanical advantage of a machine. We also have another formula that is called the velocity ratio. The velocity ratio of a machine is the distance moved by the effort divided by distance moved by the loads. The velocity ratio of the machine is the distance moved by the effort divided by the distance moved by the load. Class, in order to overcome the load, the effort can cover a distance. In order to overcome the load, the effort can cover a particular what? Okay, I want to go and pick up that bag. The effort is going to carry up the bag. The bag is the load. Distance moved by me from this point to this point is my distance moved by the what? Effort. When I now carry the bag, I now move the load to another point. That's distance moved by the load. So in machine, you can have distance moved by the effort and distance moved by the. So the velocity ratio is what gives us the relationship between distance moved by the effort all over distance moved by the. Then we have efficiency. The efficiency of a machine is the mechanical advantage divided by the velocity times 100. The efficiency of a machine is the mechanical advantage divided by the velocity ratio times 100%. Efficiency. Class, no machine is 100% efficient. A machine that has 100% efficiency is called an ideal machine, in case you ask in the exam. A machine that has 100% efficiency is called an ideal. But no machine is 100%, but just if they ask you. You know, when you are studying a calculation course, you will think that everything will be calculation. They will use one funny theoretical thing to finish you. Same thing with chemistry. Like I was teaching chemistry yesterday, and I was teaching them discovery of all those subatomic particles. Those kind of funny questions you see in your chemistry. If you study in your chemistry past, you see some funny questions that don't have any calculation. That's discovered this. State 2 Lavoisier spotulates. Have you seen some of those things in your passage? They don't have anything to do with calculation. If you don't know, you don't know. You can't get it. So we're looking at yesterday. We looked at what Rutherford discovered, right? Millikan. If you missed the chemistry class yesterday, I've uploaded the video on the members group. So if you have registered for our class fully, message me. Let me add you to the registered members group. Any class you miss, you can see it's recorded. Why are we doing this? So that you can still have access to the class. But I know that from next week now, almost everybody is done with all their practicals, right? From next week, except you did miss your practical and you're doing makeup. From next week, most people should have been running up chemistry at least. Biology, physics. So that we can enter exam focus mode. But once you are all done with your practical, we enter exam focus. We'll call it marathon exam focus class. Marathon exam focus. That one is towards exam period. That's when we'll bring in your shortcut, mathematics shortcut, physics, vectors, how you can solve calculator with vectors, how you can break down chemistry, Lewis structure, You understand? So it will be exam focus from once everybody's done with practical so that nobody will miss. Now, class, efficiency is mechanical advantage divided by velocity ratio times 100. We also have what we call work input and work output. Work what? Class. We know that work done is force times distance. Class. Work done is force times. The work input of a machine, let's call it WI. W what? Is the effort multiplied by the distance moved by the effort. And the work output of a machine is the load multiplied by distance moved by the what? Loads. Class. Work input is effort times distance moved by the what? Effort. And work output, load times distance moved by the load. Because it's important to know that there's another formula for efficiency. Work output divided by work input times 100. Efficiency of a machine can also be determined by work output divided by work input times what? 100%. Now, class, it's possible to put in a work of 500 joules. You put in a work of 500 joules, but you are getting out a work of 300 joules, and you are surprised what is going. Class, work normally for an ideal machine, the work output should be equal to the work input. Class, for an ideal machine, the work input should be equal to the work. For class, when the disparity between the work input and the work output, just know that friction is what caused it. No machine is 100% efficient, class. You put in a work of 500 joules, we are getting a work of 300. Why is this one reduced to 300? Because of work done against friction. There's a third work we call the work done against. Class, why the machine is trying to overcome the load, is also trying to overcome friction between moving parts, class. So the machine is trying to overcome the load, also trying to overcome friction between it moving. So it's doing two things, overcoming the load, also overcoming friction, class. Remember that the frictional force always acts opposing to the motion of the body. If the machine wants to carry the load in this direction, the frictional forces within the parts want to move it in opposite. So to overcome that load, it must first overcome the friction to move the load. So class, work done against friction is work input minus work. The work done against friction is the work input minus work. So you put in a work of 500 joules, but you are getting only 300 back because 200 has been lost to what? Friction. Have been lost to what? 200 joules of energy was used to overcome friction first before the load could be lifted by the machine. Having done this, let's now go to types of machine and their velocity ratio. Types of machines and their what? We have the pulley. We have the hydraulic press. We have the screw jack. We have the wheel and axle. Each machine, we have the inclined plane. The inclined plane. It's surprising to know that even the human arm is classified as a machine in physics. The human arm is classified as a third class lever in physics. Because we have first class lever, we have second class lever, and we have third class. What makes you a first class lever is the relationship or dynamic between the load, the effort, and the pivot or the fulcrum in between. When the pivot is between the load and the effort, we call you a first class lever. When the load is between the effort and the pivot, second class lever. And when the effort between the pivot and the load, we call it third class lever. Dash, which of the following is a first class lever? A, this, B, this, C, this. For example, if we ask you scissors, is it a first class lever, second class lever, or third class lever? Scissors. Nutcracker. I'll give you an assignment. Class, go and study types of levers and the example. The next class I'll ask you. At least something should make you read. Because people, there's no time to read. The school doesn't even give you time to what? Read. Go and read that one. Types of levers. First class lever, second class lever. Those ones doesn't have calculation. Something you can read. And the examples I ask you in the next physics class. We now have physics on Fridays. Every Friday is physics. So take note. Tomorrow is Saturday. We have class. Some of you don't joke with Saturday class. Exam is getting closer. Things you don't used to do before, start doing them. Exam is getting. Which day I just drove into school in the night and I was impressed. People were reading. In the class, people have started reading, going for night classes, studying. Came to some of the halls and in there, there's even light. They put light for so people can read. I just came around, drove in the evening, just came to school and people are reading their books. I said, that's good. So start studying exam. This exam, we have entered exam. We enter exam. Say you want to buy textbook again. If you fail any course, you buy that textbook again. Because they will not give you the manual alone. Just like you are struggling to get manual alone now. They won't give you. So it means that you have to buy that textbook. So nobody's failing here. Nobody's failing. Nobody's failing. So start studying. Start with your past exam questions. Class, even if they don't repeat one question, they will still gain something from the past question. Even if they don't repeat. Please don't buy a question because you're expecting them to repeat question. No. Zero your mind from repetition of question. Why you are getting past question is to know the line of questioning of the lecturer. When you have studied 3, 4, 5 years of a particular course, the past question, class, there's nothing they'll ask you in the main new question that will look new. They might change the question, they might not even repeat any question, but you will now understand how they ask and what to reply. Class, there will be two types of students in the exam. One student, when they give him question, will be thinking, what should I do? Another student knows what to do because he has seen something like that be. That's the essence of past question. That's the real lesson, not that they will repeat. The repeat is just a bonus. It's just a what? But if you study passion very well, they don't even need to repeat anything for you. You still do well. You still do. So don't be reading passion hoping that they will repeat. You are supposed to use it as a study material. Anyone they repeat, thank God. So I did not even need to solve. I just pick A. Oh, they repeated in physics. Because there will be some courses they will repeat, some they will not repeat. But even if they didn't repeat, they will still set similar type of question which you have already solved. They just change the values. I still count that as repetition because something you have done before, but they changed it up to the now put 3. Force is mass and acceleration. You studied it before. They gave you mass of 50 kg, acceleration of 2 meters per second square. 50 times 2 is 100. Now in the exam, they now give you mass of 60 kg, acceleration of 3. You say, why did they not repeat it now? Multiply 60 times 3, and I say, no, they must repeat it. So you must not exactly repeat it, but by studying past question, you know how to solve those kind of, so this has to do this kind of, say, okay, this kind of, you know how to do it. Now, class velocity ratio of a wheel and axle. Let's start wheel and. So types of machine and their velocity ratio, the wheel and axle. The velocity ratio of a wheel and axle is radius of wheel all over radius of wheel all over what? Radius of the what? Axle. Hydraulic press. Is radius of the big piston square all over radius of the small piston square. Class. In hydraulic press, you have the small piston and the what? The radius of the small piston R, big piston. Alpha. How you doing now? What final year now, B? 400. Well done. Small piston and what? Big piston. We have the screw jack. And the velocity ratio, class, is 2 pi A all over P, where A stands for the radius and P stands for the pitch. A is the radius, P is the what? Pitch. Sometimes they call A the radius or the length of the tummy bar. Yes, sometimes we call it the length of the tummy bar. Some of you have seen jack before now. You know jack? That jack they used to when you have flat tire. I even have jack, so let go and bring the one in my car so you can see. They will just jack. Although they started doing modern jacks now. That's when we are studying in Nigeria here. There's jack that you do, just do it like this, just coming up. The car will be going. No, there's one that is mechanics, the old one they used to use. That tummy bar they put inside and they do it like this. The radius of that thing is. Now, we have, which one have I not mentioned? Inclined plane. Inclined plane is 1 all over sine theta class. An inclined plane is a machine on its own. Class, but they can ask you to find the velocity ratio by, so this one is the easiest question they will ask you. If they say find the velocity ratio of an inclined plane at an angle of 30 degrees, just say 1 divided by sine 30. 1 divided by what? But class, if they don't give you theta, they don't give you what? If they don't give you theta class, this is hypotenuse, this is opposite. Class, this height of the inclined plane, and this length of the inclined plane. This is the length of the inclined. Class, sometimes they can give you a question, they will not give you theta. And say find the velocity ratio of an inclined plane. Class, you know what funny thing? When preparing for exam is like a gamble. You know why? Everything you are reading cannot come out. If everything you are reading will come out, 35 questions will not be enough. Class, only chapter 1, I can set 35 questions of chapter. I can set another 35 questions of chapter 2. So sometimes being a student is almost like a bit of gambling because studying is a bit of gambling. That's why sometimes intelligent students don't pass because for smart students, someone can just pick that 2 weeks of exam. He will just be lucky to study what came out and he passed. And you think that person is intelligent than the other person. That's why as we are also doing all these things, make sure you are a bit smart. Don't be too stubborn to say you must do everything in the test, but know the key things. Like an exam focus class, I'll be making some inquiries and I will be doing what we call AOC. This is general tutorial and I'll still be doing what we call direction AOC. Because class, everything cannot come, everything cannot do what? It's not possible. Where would they set it? Only 35 questions. Your math is 30. Last year they bought only 30 in math 110 or so. Math 35. Only one chapter can bring that 35. So class, when you're studying, study with an open mind. It's possible that all these things will not even come out. It might be chapter 3, vectors that will come out. Thank God we have done vectors. It might be rotational dynamics. But our job is to finish everything, then go to your past question. Past question will reveal a lot to you too. So class, inclined plane is 1 over sine theta. But if they don't give you theta class, inclined plane is length of the inclined plane all over height. Length of the inclined plane all over what? Height. Velocity ratio of an inclined plane, when theta is not given, is length of the inclined plane. Will give you the length and the what? Given that the length is 3 meters and the height is 6. 3 divided by 6, you get your velocity ratio. Class, know that velocity ratio doesn't have a unit. It doesn't have a what? Unit. Pulley system is number of pulley, right? To get the velocity ratio of an inclined plane is number of what? What's a good example of a pulley? Or number of tons? How many of you have fetched water from a well before? I don't know, do we still have wells or they are now obsolete? We still have wells? Yes, some of us, I think when we went for Christmas village, you still used well, right? You see that the well, there are some modern, what they call that thing? I'm looking for the modern name. That thing they used to fetch water from the well, what do they call it? Yes, what do they call it in your language first? We don't have village people here. Do you have any village person here? It's called what? Eh? What's bang bang? What do they call it? Everybody's forming now. I will send all of you out. Tell me the name in your language. Bucket. Nah, no now. That's in the row now. Eh? That rope and this thing, this what they call it? Jungle. What I mean is that the number of tons is the velocity ratio. That's the distance between the what, the effort, and the load. Class, let's take some questions on machines now. Who is number 1 in your department? Let's know who's sitting in front. Have people started getting math number? A printing machine has a velocity ratio of 9. If it requires 20 Newton to overcome a load of 90 Newton. If it requires 20 Newton to overcome a load of 90 Newton, calculate the efficiency. If it requires 20 Newton to overcome a load of 90 Newton, calculate the efficiency. A printing machine has a velocity ratio of 9. A printing machine has a velocity ratio of 9. If it requires 20 Newton to overcome a load of 90, calculate the efficiency. Please, another question quickly. Let's take these two as the odds. A machine with a velocity ratio of 5. A machine with a velocity ratio of 5. Quickly. A machine with a velocity ratio of 5 requires 1,000 joules of work. A machine with a velocity ratio of 5 requires 1,000 joules of work. A machine with a velocity ratio of 5 requires 1,000 joules of work to raise a load of 500 Newton. To raise a load of 500 Newton through a vertical distance of 1.5 meters. Through a vertical distance of 1.5 meters. Through a vertical distance of 1.5 meters. I'll come again. A machine with a velocity ratio of 5. A machine with a velocity ratio of 5 requires 1,000 joules of work. Requires 1,000 joules of work to raise a load of 500 Newton. To raise a load of what? 500 Newton through a vertical distance of 1.5 meters. Calculate the efficiency. Find the efficiency. You bent this thing. Find the efficiency. Are we solving? Make sure you're solving, make sure you're solving. What's the first question? Someone help me. The velocity ratio of what? A printing machine with a velocity ratio of, yes? It requires 20 Newton, our effort is 20. Overcome a load of what? You can see that the effort is usually lesser than the load because of the machine that will help us overcome a large load with a little. What they ask us to find? Efficiency. I'm sure you did the mechanical advantage here, right? The mechanical advantage is a load all over 90 over 20 looks like 4.5. It doesn't have a unit, right? So efficiency now will be mechanical advantage all over velocity multiplied by 100. Mechanical advantage is 4.5. Velocity ratio is multiplied by 100. So efficiency is 50 what? Percent. You know that for like 2-3 years straight, they brought machines after they stopped bringing machines for under 2-3 years. That's why I say exam, they cannot set from everywhere. Like the last 2-3 years, they have not brought machines again. It might be this yourself that they bring machine back. Where I brought this question from, where I had to go back to the person to 3 years ago, 3 sets ago. Because lecturer can't set 35 questions, some topics will be missing, definitely. So they circulate. That way it's good to know everything so that anyone that comes out, you are still good. But still study the person to have direction to. Now, what's second question? A machine with a velocity ratio of what? 5. VR is 5 now. A machine with a velocity ratio of 5, yes? Requires 1,000 joules of work. Requires 1,000 joules of work means the work input is 1. Yes. Continue. To raise the load of what? Load is 500 Newton, yes. Through a vertical height, distance moved by the load is 1.5. Through a vertical height of 1.5. Find the efficient. Class, this is a distractor. You don't use this thing for anything. Efficiency you use here is work output over work input times 100. Class, my work output is load multiplied by distance moved by the load. My work output is load multiplied by distance moved by the... That's 500 times 1.5. Giving you 750 joules. Class, to be sure, our work output is always lesser than our work. Class, it's important first step in solving this question is to note and recognize that this 1,000 joules they give you is your work input. Because it requires 1,000 input, requires to put 1,000 joules of work to lift a load of 500 Newton through a vertical of 1.5. So the work output is load multiplied by distance. It's also important to recognize that this height, through a vertical height, is the distance moved by the load. So the load was moved through a vertical height of 1.5. So work output is load multiplied by distance moved by the load. 500 times 1.5 is 750. Class, we now say efficiency is work output all over work multiplied by 100. What's our work output? 7. What's our work input? Multiplied by 100. This looks like 75%. Right? Because 750 times 100 divided by 1,000 is 75. Because 750 divided by 1,000 is 0.75. 0.75 times 100 is 75. So my efficiency is what? 75%. We are done with work, energy, and power.